Welcome back to the deep dive. Today, we're going way, way back, like hundreds of millions of years back. We have some fascinating sources about something, well, something huge and really strange.
Yeah, we're on a bit of an archaeological dig, you could say, trying to piece together the story of this extinct giant that was, as tall as a two-story building. It basically ruled its world.
And this giant, it's called Prototaxites. And here's the kicker. It wasn't a tree. It was this massive ancient fungus, like a giant mushroom.
And an absolutely enormous mushroom. The sources say they could be anywhere from, 2 to 9 meters tall?
9 meters. That's like a telephone pole. And maybe a meter thick. Just try picturing that. Walking through this ancient, sparse landscape. And the biggest thing around is a mushroom the size of a streetlight. Let's dig into this.
Okay, so to really get prototaxites, you need the context. We're talking about the Devonian Period,
Right.
which was a huge slice of time, about 60 million years, starting roughly 419 million years ago.
The planet back then looked totally different, didn't it? Almost alien compared to now.
Completely different. You had the land masses sort of clumping together into Laurasia, that's like North America and Europe, and Gondwana down south.
Okay.
But mostly it was water. They call it the age of fishes for a reason. Something like 85% of the Earth was ocean.
Wow, 85%. So the land, what was going on there? Sounds pretty empty.
It really was. Very sparse. Life was just starting to get a foothold on land, but it was all low-lying stuff. Think small, non-vascular plants, almost like mosses or ground cover.
No trees yet?
No proper trees, no forests. The biggest things crawling around were tiny, relatively speaking. Wingless insects, arthropods, maybe some early spider-like things.
So you've got this flat, kind of muddy, low-green landscape, and then bam, these giant fungal towers.
Exactly. Prototaxites would have just dominated the skyline, such as it was. They were literally the tallest things on land.
They must look so out of place, like these massive, weird pillars standing out against this flat world.
Yeah, like a bunch of freaky sore thumbs, basically. And that visual is key because it brings up the big question.
Right. If there weren't any tall trees to compete with for sunlight.
Precisely. Plants grow tall to get sun. These things weren't plants, so why on earth did they need to be so gigantic? What was the point?
And that question leads us into this amazing bit of scientific history. A proper, 150-year-long argument. This is where it gets fun.
Oh, yeah, the science-y beef, as you might call it. It all started back in 1855. A geologist, J.W. Dawson, found this incredible fossil up in Gaspé Bay, Canada.
How big was it?
About 6 meters tall, half a meter wide, huge.
Okay.
And Dawson looked at it and thought, well, it's got to be a tree, right? A conifer. He called it Prototaxites, which means early yew.
But the inside wasn't witty, was it? That was the problem.
Exactly. It was kind of loose, filamentous. So
Yeah.
Dawson figured, okay, it must have just rotted before it fossilized, leaving this weird texture.
Makes sense as an assumption, I guess. But not everyone agreed.
Not at all. Fast forward to 1872. Enter William Carruthers, a paleobotanist, and he basically came out swinging. He pretty much said Dawson, the geologist, had no clue about plant structure, that he should stick to rocks. Carruthers insisted it had to be marine algae.
Algae. But didn't they find it on land?
Yep, the evidence pointed to land. But Carruthers ignored that and even renamed it Nematophyton, meaning filamentous plant.
Ouch. That's pretty harsh. How did Dawson take that?
Not well. The sources have this amazing quote from Dawson's response. He called Carruthers' tone unnecessarily offensive and said Carruthers was making unfair assumptions that I am ignorant of some of the most familiar facts of structural botany,
Oh.
facts which were well known to me while he was yet a schoolboy.
Oh, snap. That is some serious academic shade right there.
Totally. A proper smackdown. But believe it or not, despite Dawson fighting back, Carruthers' idea that it was some kind of plant or algae kind of stuck around as the main theory for over 100 years.
Wow, over a century. So how did they finally figure it out? Wasn't just looking closer, I take it.
No. The breakthrough didn't come until the early 2000s, confirmed in 2007. And it wasn't anatomy, it was chemistry. Specifically, isotopic analysis. Looking at carbon.
Carbon isotopes. How does that work?
Well, it's actually pretty neat. Basically, different kinds of life get their carbon in different ways, leaving slightly different isotopic signatures, like different ratios of carbon-12 and carbon-13.
Okay.
So plants pull carbon straight from the air via photosynthesis. All the plants in one area will have a pretty similar carbon signature.
Right.
Animals get carbon from eating stuff, so their signature matches their food.
Makes sense.
And then there are fungi. They don't photosynthesize, and they don't really eat like animals. They absorb nutrients from whatever they're decomposing. Their carbon comes from that.
So they check the carbon signature in the Prototaxites fossils.
They did. And guess what? The carbon signature was totally different. Radically different from all the known Devonian plants found nearby.
No way.
Yes way. It proved, pretty much conclusively, it wasn't a plant. It wasn't algae. It wasn't getting carbon from the air.
So it had to be a fungus, getting its carbon from dead stuff.
Bingo! That isotopic signature basically shouted fungus.
Oh.
It settled that 150-year debate.
That's incredible. Forensic chemistry solves the giant mushroom mystery. So, okay, if it's a fungus, how did it live? You said decomposing stuff.
Exactly. They were likely saprotrophic. That's the term for organisms that feed on dead or decaying organic matter. Think of them as nature's recyclers.
Like mushrooms breaking down logs today, but on a massive scale.
Precisely. And to do that, fungi have these extensive underground networks called mycelia.
Right, the thread-like stuff you sometimes see in soil.
Mm-hmm.
That's the main body, isn't it? The mushroom part is just for reproduction.
You got it. So these mycelia spread out, release chemicals, break down dead plants or whatever, and absorb the nutrients and carbon. Now, imagine the size of the mycelial network needed to support a 9-meter-tall fruiting body.
It must have been absolutely enormous.
Yeah.
Spreading out under the ground.
Huge. Which brings us back full circle to that why so tall question, if they weren't reaching for sunlight.
What was the advantage of being 9 meters high?
It probably comes down to reproduction. Spore dispersal.
Ah, like puffballs releasing spores.
Sort of, yeah. For fungi, height is a huge advantage for spreading spores. The taller the structure releasing the spores, the higher up they get caught by the wind.
And the further they can travel to colonize new areas.
Exactly. On that flat, relatively empty Devonian landscape, being 9 meters tall meant your spores could potentially travel vast distances, way further than spores released near the ground. It was a massive edge for colonization.
So they were basically giant spore towers dominating this ancient world for millions of years. Unrivaled. But obviously they're not around anymore. What happened?
Well, nothing lasts forever, right? Towards the end of the Devonian, things started to change. The world got more complex, and that spelled trouble for prototaxites.
Competition finally showed up.
That's a big part of it. Remember how we said there were no real trees? Well, during the Middle and later Devonian, vascular plants, actual trees and shrubs with woody structures, lignin, they started evolving and taking off.
Ah, so suddenly there was competition for space and height.
Yep. These new trees could grow tall and sturdy. They started forming the first forests. And that created two big problems for the giant fungi. First, direct competition for physical space.
Okay.
And second, shade. For the first time, large parts of the land surface were being shaded by these new forests.
And prototaxites fed on the low-lying ground cover plants, right?
Yeah.
So the shade would kill off their food source.
You nailed it. Less sunlight reaches the ground, the small plants prototaxites likely relied on start to dwindle, so their food source shrinks, and they're getting crowded out. It's a double whammy.
Oof. Was there anything else?
There's another factor, a bit darker maybe, predation.
Things started eating them.
Seems like it. Remember those early insects and arthropods? They were evolving too, and scientists find fossils of prototaxites that have little boreholes in them.
Like somebody was drilling in and munching on them.
Exactly. So imagine you're this giant fungus taking a huge amount of energy and time to grow 9 meters tall, and now you've got less food, you're being crowded out by trees, and little critters are constantly nibbling away at you.
Yeah, that doesn't sound sustainable.
Yeah.
Especially if they grew slowly.
Probably very slowly. So competition, loss of food source, and possibly predation, it all likely contributed to their decline and eventual extinction as the Devonian world turned green and forested.
What an absolutely incredible journey from giant mystery fossil to confirmed colossal fungus that ruled a lost world. And a 150-year scientific argument settled by carbon atoms.
It really is amazing. And, you know, thinking bigger picture, the story of prototaxites is kind of a wild example of how life can just explode into unexpected forms when there's an open ecological niche. Giant fungi ruling the land, who would have guessed?
Right. It challenges our neat little boxes of plant, animal, fungus.
Exactly. And it makes you wonder, doesn't it, how many other bizarre giant life forms might be hiding in the fossil record, misclassified because they don't fit our modern expectations. What else might be out there, waiting for the right kind of chemical analysis to reveal its true, strange nature? Something for you to think about.
Definitely something to mull over.
Yeah.
A fantastic journey back in time. Thanks for walking us through the sources on these fungal titans. We'll catch you on the next deep dive.